using the factor theorem to solve a polynomial equation. The factor theorem is another theorem that helps us analyze polynomial equations. It tells us how the zeros of a polynomial are related to the factors. Recall that the division algorithm, f of x being the dividend, is equal to x minus k times q, which x minus k is the divisor, times the quotient plus the remainder. Now, if k is a 0, then the remainder r is f of k equals 0, and f of x is equal to x minus k times qx plus 0, or f of x is equal to the divisor times the quotient. Now notice, written in this form, x minus k is a factor of f of x. We can conclude if k is a 0 of f of x, then x minus k is a factor of f of x. Similarly, if x minus k is a factor of the function f of x, then the remainder of the division algorithm, f of x is equal to x minus k times q of x plus r is 0. This tells us that k is a 0. This pair of implications is the factor theorem. As we will soon see, a polynomial of degree n in the complex number system will have n zeros. We can use the factor theorem to completely factor a polynomial into the product of n factors. Once the polynomial has been completely factored, we can easily determine the zeros of the polynomial. So the factor theorem. According to the factor theorem, k is a 0 of f of x if and only if x minus k is a factor of f of x. So let's take a look at a couple examples. We want to determine whether x plus 1 is a factor of the polynomial 3x to the fourth plus x cubed minus x squared plus 3x plus 1. So we first need to figure out what is the value of k. Well, remember that this is x plus 1. Okay, if we want to set it equal to 0, then that means the value of k is going to be negative 1, or recall that this is x minus a negative 1. And so now what we're going to do is we're going to use the remainder theorem. So in step number 2, we know the value of k then is negative 1. So now instead of using synthetic division, we can use the remainder theorem by using negative 1 as the input of the function. So it's going to be f of negative 1 and then plug it into the function. So it's going to be 3 times negative 1 to the fourth power plus negative 1 to the third power minus negative 1 to the second power plus 3 times negative 1 plus 2. So 3 times negative 1 to the fourth power gives us a positive 1. Plus negative 1 to the third power gives us negative 1. And this is minus negative 1 squared is positive 1. And then positive 3 times negative 1 is going to be positive plus negative 3, and then plus 2. So now let's go ahead and then simplify a little further. So 3 times 1 is 3. This is minus 1, minus 1, minus 3, plus 2. So if we have 3 minus 1, that gives us 2. 2 minus 1 is 1. 1 minus 3 is negative 2. Negative 2 plus 2 is going to give us 0. Now, since we evaluated f of negative 1, meaning if we plugged in the value of k and we got 0, which is our remainder, if that's the case, then the factor theorem tells us that x plus 1 is a factor of that polynomial, again because we got 0 as a remainder. So therefore here we can say that x plus 1 is a factor of this polynomial. Let's look at another example. It says check whether x plus 1 is a factor of this polynomial, x to the sixth plus 2x times x minus 1 minus 4. Now again, we got to find the value of k. Well, the value of k is setting x minus 1 equal to 0, x plus 1. And so we get x equals negative 1. And we can see that the value of k is negative 1. And now we're going to plug in the value of k as an input of that function. So it's going to be negative 1 to the 6th power plus 2 times negative 1 times negative 1 minus 4. So let's go a little further here. So we got negative 1 to the 6th power, which is positive 1. And plus 2 times negative 1 is going to be negative 2 times minus 1 times minus 1, which is negative 2, and then minus 4. And this becomes 1. Negative 2 times negative 2 is positive 4, minus 4. And so the answer is 1. So f of negative 1 gives us a remainder of 1. Now, since we didn't get a remainder of 0, then we cannot say that x plus 1 is a factor of this function. So we can say that, therefore, x plus 1 is not a factor because we did not get a remainder of 0.